Hello, I am Mr. Cooper. I am a teacher in mathematics, computer science, robotics, lots of things. But mainly I'm here just doing a quick video on, my mother told me that her sister, who's, in her 60s or so, never understood algebra, just simple algebra her whole life, saying that logic doesn't compute. And that kind of hit me, because logic, as long as you're not abnormal brained, as long as you don't have some mental condition, logic and simple algebra should come to you. She probably had terrible teachers and just never learned, and that's why I believe it is. All I am doing here is I want to teach her, and if she doesn't understand it, then so be it. I tried. That's my goal as a teacher. Is just to teach, and hopefully I can help her learn. And if she doesn't learn, well, I tried. So anyway, let's get on. So this is going to be a very, very basic, I guess, algebra problem. I will eventually write an algebra, but I'm going to do pictures and stuff first, and just to make things as understandable as possible. So, like any math problem, it starts with a question. And with every question, and there is an answer or a solution. There isn't always a solution in mathematics, but there isn't this time. There is this time. So the question is, I have a dozen apples, and I don't know, three friends. I need to give these dozen apples, which is 12 in America. I don't know if different countries are different, but 12 apples. I need to give them to three different friends, evenly, distribute evenly. How many apples do I give to each one of my friends? All right. So in mathematics, first thing in elementary mathematics you learn is to write down what you know. Always write down what you know. So 12 apples. All right. And I have three friends. I'm just going to say people. Oh, geez, I can't spell people. Yeah, I know the E comes first. All right, people. All right, three people. So, and the question is, how many apples? How many apples per person if I distribute it evenly? I'm not going to write all that. I can barely write. You can tell my writing is something I should forget it. Something I should practice, but whatever. I type more than I do anything. So here we go. So let's without doing any algebra, let's just kind of draw it out. Let's draw it out. 12 apples. 12. And then I'm going to draw an apple, my best apple I can draw. Oh, kind of looks like a heart. I don't know, whatever. It's a Red Delicious, huh? It's got that point. Red Delicious had that point. So 12, so this is actually algebraic notation. This means 12 times apple. If you have nothing in between, it means times. And when you have 12 times, and this is just one apple, so 12 times 1 is 12. 1 times anything is itself. So 12 apples. So 12 times apple. 12 times 1, I have 12 apples. All right, is equal to, all right, this is equals is big part of mathematics in general. Geez, equals is one of the most important parts of mathematics. It is equal to, I need to figure out that 12 apples is equal to 3 people. People, how do I draw people? I'm just going to draw a single person. Why a single person, not a crowd? Because this is the same like the apples. 3 times 1 person. I have 3 people. All right? 3 people. This represents 1. This represents 3. And this is multiplication. So 3 times 1 is 3 people. 12 times 1 is 12 apples. Okay? In algebra, we would write normally these as letters. A, P, A for apple, P for person, you can, whatever letter. There's certain letters you shouldn't use, but for the most case, and you probably see X all the time in the beginning because X is one of the main variables we use. All right, so what do? So the goal here, let's think of the goal. The goal is how many apples per person. Person means one. Not 3, 1. So if I can solve how many apples each one person gets, since it's distributed evenly, then I can solve how many everyone gets because we're all getting the same. So the goal is to find one person. So let's look at this. I have 3 people. I want one person. So I need to get rid of this 3. So in algebra, we can get rid of a 3. So this 3 is being multiplied. So what we do to one side of the equation, we can do the other side of the equation because it is a balance. What you do one side, you do the other side. It stays the same. If you do one side and you don't do the other side, boom, it is no longer true. But this is what makes math so beautiful. It stays true no matter what you do as long as you do the same thing to both sides. It just stays true. It's like, for instance, 1 is equal to 1. I don't know. Let's add 1 to both sides. Plus 1 plus 1. And now we're at 2 is equal to 2. No matter what we do, as long as we do the same thing to both sides, it is true. So the same thing's going to happen here. As long as we do the same thing to both sides, the equation is true. So again, we want one person. So one person, we have 3 being multiplied. We need to do the opposite to get rid of this 3, and I'll show you in a second why. So to the opposite, we need to divide by 3. It's being multiplied by 3, we divide by 3. And notice I did it both sides. This 3 was, because I can't just do it one side. As shown before, it would be wrong. You got to do both sides. And now we're looking at this chaos. Like, oh man, a lot going on here. But remember, a number over a number, no matter what number, as long as it's not 0 on the denominator, like let's say 4 over 4, it's equal to 1. 4 divided by 4 is equal to 1. So it always cancels out. Yeah, because multiplication multiplied by 1 cancels out. So 3's just cancel out because this just becomes a 1. One person. All right, so now on this whole right-hand side of this literally equation, there's just one person, which is what we're looking for. One person. Oh yeah, one person. We still got this left-hand side of the equation. So that's we have 12 apples divided by 3. Well, what's 12 divided by 3? 4. Now we have 4 apples. It's equal to, now let's look back at over here. 3's canceled out. Just a single freaking person. Well, boom. So every one person gets 4 apples. All right, and that's simple. And